area. We have a large engineering team out of Israel, but then I'm here. We got Jason and Dave in the Boston area as well. We're participating in this event. We love the community. Thanks, Chris. There's more and more kind of data activities or community things happening in this area. So, you know, what that is. How do I get rid of that? Press, you see that? There's no touch screen, is it?
Right, I'm impressed you didn't try.
Yeah. Like my kids, it's just touch screen. All right, I'll keep talking. So you'll see in a minute when I introduce myself. My LinkedIn profile is there, Jason's as well. Follow us if there's any like Boston area community things going on. We'll try to post there. So you know, come in and enjoy.
Right, that's on your computer. So if they hit the don't leave the meeting.
I think it's this one.
Oh,
There you go.
got it. Very good. Cool. So the topic today is around data mesh. So data mesh is a concept that's been around for a long time, but it's really been talked about kind of at high level with kind of general terms. But what I want to do is kind of bring that idea down to earth and help you understand what does that mean for you. If you were to start tomorrow, where would you start, right? There's no one answer to everything, right? This is just an approach, something that you can try, but yeah, hopefully help you get started. Cool. So again, my name is Roy up there. Got Jason here as well. So Jason's going to jump in towards the end to actually go through a demo. So everything that we talk about here at the end, we want to actually show it to you live and working. So he'll do that in a bit. I'm previously from AWS, Amazon Web Services, worked around here a lot with many companies. Worked on kind of the early days of data lakes and data mesh at AWS, kind of helped figure out which products fit where, how do we put them together, worked with a few customers, you'll see an examples in a bit, on kind of taking that idea when it was first introduced and applying it using AWS services to real world examples. And that's kind of what I'm trying to do here, is kind of show you taking those examples and how to help you get started. Cool. So the big thing here is that, you know, when we talk about data mesh, it was really designed to help solve some specific problems. It came out of, basically Martin Fuller as a consulting company. They announced kind of like what data mesh is. It's really an idea to kind of solve some organizational problems. And I want to kind of highlight this to kind of give you an idea of what are we trying to solve, right? So if we look at it, many times we talk to our business users, and what do they tell us, right? They tell us, you know, it takes too long to get access to data, right? I'm running my queries, they're too slow, right? Central IT or the data team, too slow, taking too long to respond to my needs. And then you turn around, you talk to the engineering team, what do they tell you, right? They say the same thing. We don't understand what the business wants. They throw these requirements over the fence, and then we're left to kind of figure it out. We don't have anybody to really talk to. There are too many requests, right? Business user comes in, I want this dashboard. Then I want to change the dashboard. I'm not sure, that wasn't quite right. Let's do it again, right? And they get overwhelmed. So it's kind of like finger pointing, right? Business is saying, engineering is not doing anything. Engineering is saying, business is not giving me anything, right? We really got to stop that. So data mesh in its idea was about trying to solve these bigger organizational problems. So it's not really a technology, it's not really an architecture or a product per se. It's a concept, it's a pattern, it's a way to solve bigger business problems through technology, through best practices. And that's what I'll try to talk to today. All right. So when we talk about data mesh, oftentimes you search on Google data mesh and you get links to different vendors who are claiming they are data mesh. They can do data mesh. That is the solution for data mesh. So you often find data lakes, right? In data lake, you can think about it as kind of build your own, right? There's storage, there's metadata, there's compute, and then you can do whatever you want. So you pick which vendor you want, you stitch them together. But the idea of a data lake is that all those components are separate. But the integration, the wiring, the connection between all those things are really up to you. Nobody says this is, what to do. You just kind of read, you learn, and you do it on your own. So for a large company that has resources and engineers that want to do it, they get a ton of flexibility from following the data lake model, right? But again, it's a technical solution. It's not what data mesh is. Similarly, you probably hear a lot about Lakehouse. That's something that Databricks sort of published or talked a lot about. And again, it's more of like a vertically integrated solution, but it takes kind of the idea of a data lake, the coupling of the layers, and it wraps it in Databricks, right? So if you come in and say, but I want a data lake, I want that experience, but I'm not really ready to build it on my own. I want a vendor to come in and kind of give it to me. Databricks offers. And other vendors come in and kind of say, yes, we can package this idea into a product. So it's easier for you to come in and say, I got one vendor to deal with. If I have any problems, any questions, I go to one person or one company, and they're going to help me deliver, right? Faster time to market, but you also get kind of the openness and the flexibility of the data lake platform. And then on the far right, you get this data warehousing, a little bit of a hybrid model, right? Snowflake came out, Redshifts been around for a long time. They said, hey, we're a data warehouse, we're analytics, we're everything. Call us a data lake, call us whatever you want. Just bring it all in, right? Sounds great on the surface, but you kind of lose some things, right? You give up some things to get that ease of use. So where this platform makes a lot of sense is when you don't necessarily have a data team. You don't necessarily have the ability to go and build on your own and integrate. You just say, I want one vendor. As long as it's logically separated and it scales fine, I don't really have to worry about anything else. So kind of like a little bit about these solutions, but why do they not work on their own? So when we talk about data mesh, it's not just the technology as you've seen a little bit. Like these technologies are really about solving specific data problems. Remember in the beginning, I said that data mesh is around solving organizational problems, like or problem with your organization, right? How do you get people to talk to each other? How do you get it to work better? What frameworks, what patterns can you put in place that will make it more agile and more conducive to innovate and to work together? So, on a data lake side, right? Too much technology, a lot of integration. You got to learn all these products. You got to be good at them. You got to understand how they work, performance, scale, cost, how to put them all together, right? But it also encourages kind of this inconsistent implementation. So if you're a large company and you have one line of business that wants to build data lake and another one that wants to build their own, because there's so many options, you probably will end up with two different solutions, right? And when you end up with two different solutions, two different cost models, right? This may be expensive, this may be cheap. They may both be super expensive. You can't apply best practices very well because they're two different things, right? Performance, you got to test everything because you don't know how it's going to perform at scale. But if you have a consistent platform, you can test once and then it applies to all of your business units, whatever you end up implementing. Lakehouse, again, fewer tools, fewer choices to pick from. So it's a little bit easier to make a decision around it. It does encourages centralization, which is an okay thing, right? We're kind of saying this is a common platform, a common kind of architecture, but it also encourages lock-in, right? You're saying, hey, Databricks is offering me all these options. It's nice and easy to use, but it does kind of lock me into the platform. If tomorrow I want to go do something else, it's a little bit harder, right? Now they do save things, save your data in open formats. The metadata is in open formats, so it's easier to access, but it's still within their platform, right? And then the last one on the hybrid side is really like 3 to 4 vendors, right? Snowflake, Redshift, BigQuery, Azure Synapse. It's a great platform, easy to get started. You don't really have to be an engineer. They kind of just host it for you, and you just shove data into it, and you're kind of done, right? But it's a lock-in, right? It's limited. It's like an ivory tower, right? There's only one road to it. And if you want to get data out in different ways, well, you got to go through them. If you want to analyze the data, you want to process it in different ways, you've got to go through them. It's great for them because data is a lock-in, right? Your needs are locked into their platform. It's great for you because it's easy to get started, but it's not great for you as you grow and you want to do more. Now you're kind of locked in. You got to figure out how to keep working around this platform and keep like binging it and piling things on top, kind of bolting solutions on because you want to do more and the platform is limited. So that's kind of the thought process there. This is a bit of an eye chart, but this is a diagram from A16Z, which is a VC firm. Basically, kind of trying to define what the unified data infrastructure looks like. And don't try to read this, but it's just a bunch of boxes, a bunch of tools, and arrows between them. Many times when we talk about data mesh, people think this: I need to go build this. Like, you don't need to go build this, right? This is great. This is trying to kind of cover everything in the market, all the different tools, how they all kind of interact together. If you want to build a platform on your own and you got the capacity, go for it. This is a good roadmap. But for most people who want to get into data mesh and take the benefits of data mesh, this is not the way to do it. So this is from kind of the original paper on data mesh. Kind of stole this. There's a link below. I think you get the slides later, so you can kind of follow that link. But pretty much, if you look at this, there's some technical terms here, but in essence, it's a pattern that allows different groups within the company, whether it's microservices teams, lines of business, a large company, whatever that may be, to kind of work together and say, we're our own individual units, right? But we're going to build interfaces and contracts between us so we can talk intelligently, right? And then on the bottom, you kind of have this common infrastructure layer that allows you to standardize your technology. So not every group has their own stack. You have a common stack that's easy for you to service, easy for you to secure and manage, and then everybody can kind of learn from that. So we'll kind of get into that in a minute. If people want to sit down or come in, sorry, I don't mean to put you on the spot, but if you want to.
Are these seats open over
Yes.
here? I don't want to disturb everyone.
No, all good. Cool. So hopefully people can kind of see this. So coming back to like data mesh. So data mesh is around flexible organization design pattern that enables kind of self-service tooling, right? And what does that mean? So like data domains, those are kind of the organizational units to say, I got multiple lines of business in my company, or I have maybe a smaller company, I have microservices. I got the payment team, I got the recommendation team, I got the backend team. Those can be considered data domains. They need to be operating autonomously, independent of each other, right? Like, we don't want to have tight coupling between them from a data analytics perspective, because if one team wants to produce a data set or consume another one and do something with it, they can't be very tight to the other one. Like, how do we build decoupling between them? So something that APIs did for us many years ago and still does it for us now is it gives us that decoupling. If I need to give somebody an API to access my service, I define the API and I define what the structure is, what the data model is, what the REST API components are, like how do I get values, how do I put values, and that's my contract. That's how I speak. If you want to talk to my service, that's how you speak to me. Today, we don't have that in data, right? So, if one, let's say the payment microservice wants to give the marketing team access to the data so they can do some analysis, how do they do that? They take the data today, they shove it in the data warehouse. They said, it's done, go do something with it. And if the marketing team comes back and say, I don't understand what all these columns mean, I don't know the relationship between them, then they have to start talking to each other. They have to model it together. And that takes a long time. But if we build these structures, these processes where we build contracts, like actual technical contracts between them, it's much easier for the payments team to come in and say, this is how we define our schema. This is how we define the data model. Right? It's easier for the marketing team to understand that. If they want to change it and tweak it, they can have that conversation. But for the most part, this is what my data means. It's an API. Right? Data infrastructure is a platform. Something that you see often is, central teams will build a data platform and say, everybody needs to come to us. We will manage it. If you have a problem, come and talk to us. Right? But we said already that it doesn't work. We already said that we need to decouple. We need to distribute that. We need to have each microservice or each line of business, data domain, have their own platform, have their own ability to say, I'm going to take data from my database, I'm going to transform it, I'm going to model it, I'm going to clean it, maybe I'll redact some things because nobody can see some of these credit cards, for example, and then I want to serve it, right, to the marketing team. I need a platform, I need a way to do it. I can't be dependent on a central data team to do it for me. because they don't understand my business. They don't know what I need to do, and I need hands-on, right? So if you have this data infrastructure as a platform, you're basically saying, I'm going to give you the building blocks, and I'm going to make those building blocks self-service and easy to use. So if the payments team wants to build data ETL, data transformation, they should be able to take their data, store it in S3, which is like a common storage layer for your company. And then they can bring a tool like Upsolver, AWS Glue, Spark, Flink, whatever they want to process that data. Now, me as a company, I may say, you know what? Upsolver is my recommendation, or Spark is my recommendation. If you use Spark, I can help you. If you use Spark, you get better cost, you get better performance. Here's some best practices to use Spark, right? So now each team actually has best practices. They have an infrastructure, they have a platform that they can plug into for their own needs. Is this making sense? If somebody has questions, like stop me along the way and ask. Okay. The other component, so we kind of have like this decoupling. We have different lines of business, different microservices teams or data domains doing their own thing. We have a common platform that they can all plug into and leverage. Now we have this idea of data as a product. Now I'm throwing a lot of terms at you, but this idea of data as a product basically says that if I'm the payments team and I need to give some data to my marketing team, that data can't just be a table that I throw over the wall and I say, good luck, have fun with it. If you have a problem, I don't know, call this 800 number, maybe somebody will answer. I have to be responsible. If we go back to the example with APIs, you don't see anybody offering an API and then saying, well, if it breaks, it breaks, your problem, right? No, an API is a contract. An API says that whatever is behind it, that you're responsible. If I'm offering you an API, if Facebook is giving you an API, they're responsible for that. If that thing goes down, it's their problem. The same thing with data. If I offer you a data set or offer you a stream of data or some form of data, I need to be responsible for it, right? So data as a product, we want to treat that data as we would a product. We want to think about what it needs to look like. How do we make it easy for our users to understand it, right? How do we annotate it? How do we explain it? How do we model it? How do we model it against like business entities, right? Data quality. How do we ensure data quality is up to par, and we're not introducing some bad data and then the user kind of finds out later? How do we make sure that data is reliable, right? If things go down, how do we make sure we notify the consumer that things went down and now we need to kind of wait a second, we're fixing it and we're doing it. So we have to treat it like a product. Many companies are actually taking the approach of saying, you know what, if it's going to be a product, I'm actually going to have a data product manager. Somebody that comes in and their responsibility is to go talk to the business and say, what would you like to see from my data? How would you like to consume it? How would you like to use it? Right now, we're really treating it as a product. It's not just here's a table, go have fun with it. Right? Again, you want to talk with your customers, which are your business users, many times, and say, how can I serve you? Overarching governance, I won't get too much into that, but in financial services, highly regulated environments, governance really becomes a big deal. That's a big topic. So governance is around security, entitlements, auditing, privacy controls. There's lots and lots of stuff there. It tends to get layered on top of the data mesh story, but it's really not that simple. There needs to be some kind of incremental steps to get there. And some companies don't need all of it, right? They may need access controls, right? They may need GDPR, CCPA controls to be able to delete stuff, but that's it. They may not need everything else. They may not be held accountable for certain auditing requirements. So take that with a grain of salt, but it's also a big topic. All right. So I'm going to kind of walk through a few examples. These are all public examples. You can get them online. There's a link here. I personally worked on many of these projects when I was at AWS. So I'm not sharing anything internal, proprietary, or anything like that. It's all public information. But I want to put these up as examples. Right? We always talk about data mesh. We always kind of get to the top and we stop. Right? I want to bring it down a level. So this is an example from JPMC. Kind of talk about why did they choose to go down the path of data mesh. And I don't know how easy it is to read, but I would say like the key priorities down below, like the two big items are data as a product, right? They want to change the way people are thinking and think about their data as a product, right? And the second one is around liberating the data, right? We call data democratization. And that's really the ability to say like each team needs to be independent and be able to create their data sets and free it. If it's internal data that we are going to use within our team, great. If it's data that I should be sending to other people or sharing with other people, I should be able to do it very easily. So these are kind of the high levels of why they chose to go down a data mesh path. Where'd it go? There we go. All right. So double clicking a little bit into that. On the left side, the circle in the box, these are kind of like the existing business processes. Yeah. So like existing databases, this is where all data is actually stored. Your day-to-day business stuff, right? In the middle, what we see is we see the red, yellow, and blue boxes. And those are kind of like lines of business, right? And each line of business hosts their own environment, right? So you can see here, they actually have their own data lake. They have their own catalog. They have their own analytics processes that are ingesting data, processing it, et cetera, et cetera. So each one is completely independent, decoupled from the other. And then there's this central mesh catalog, they call it, that allows you to register these data sets so others can find them and consume them. So if the red box, the red data lake wants to share a data set with the blue data lake, they don't do it point to point. They don't say, oh, here, blue guy, let's give you the data. They publish it in the central catalog so everybody can access it. So there's a certain entitlements or access controls that gets applied there as well. So if I want to find the data, let's say I'm looking for payment data or credit card data, not credit card numbers, but credit card consumption data or something like that, where do I find it? That central catalog let me find it. So those are the consumers on the right side that are saying, I need this data for ML. I need this data for analytics, right? Yes.
Are you going to be talking more about the catalog and what it is? And how it's done?
Not in a ton of details, but if you have questions on it, I'll be happy to talk about it. But there's a couple of slides that kind of talk a little bit about what it does.
Thank you.
Yeah. But yeah, stop me along the way if you want to go deeper, or we can talk after. Okay, so double clicking into that a little bit. This is again a bit of an eye chart, so hopefully you can read it. I'll try to summarize it. So if we look at those, red, yellow, and blue boxes, if we double click on one of them, this is kind of what it looks like behind the scenes. So JPMC actually took the approach of build your own data lake. Remember the three ones I gave you, the data lake, the lake house, and the data warehouse, the hybrid? They actually went down the path of, build your own because they wanted control, right? They needed access, they needed control, they need to tweak and tune. They have a lot of requirements, financial, regulatory requirements they wanted to deal with. So they did that. So kind of, it's a little bit hard to see, but there's data being consumed on the top left there, some streaming sources. Data gets brought in to the central data lake. They do data processing. I don't know if I can show it. Oh man, it's super slow. Go here. So data up top gets brought in. There's this lake formation is the authorization layer. So this is where they find entitlements. Who can access what, which columns, which rows. The central here is the catalog registration. So as data come in the top, it gets transformed, cleaned, it gets validated, data quality gets validated. There's some redacting happening and things like that. And then they get registered in the local catalog within that local data lake. So if you want to work with more data sets, if the local team wants to get access to data set, they can find the local catalog. And then they use here to do the processing, and then there's a consumption layer. So these data sets are actually made available in the data lake by having the physical data in S3 and the metadata, right? The schemas, the name of the tables in the glue data catalog / lake formation. And then users can come in and they can say, well, I want to just run queries on that data, just ad hoc queries. They can use Athena for that, Amazon Athena. They can use Amazon Redshift, right? That's a data warehouse. So they can say, hey, you want to use Redshift? Sure, I'll take that table, I'll load it into Redshift for you so I can run fast queries. If you don't really want, it's kind of ad hoc queries. I don't want to pay for Redshift to store that data. I'm going to leave it in S3 and I'm going to use Amazon Athena and run queries against it, right? And that's kind of how they allow other users, either internally within the one red data lake or outside of it, to consume that data. Does this make sense? Questions, thoughts?
So that consumption layer, that's data warehousing
So-
layer.
So this consumption layer can really be anything.
Okay.
So you can see like Redshift here is a data warehouse. There are use cases where I want to put the data in a data warehouse because there's a lot of BI applications like dashboards.
Right.
And because I store it there, I don't have to keep scanning it from S3 and paying extra money, right? And it's much faster because it's cached. So like this will be here, then you'll build some dashboards on top of that. This is more like ad hoc. So if you're doing machine learning and you're sitting in a notebook and you're saying, you know, I just want to run a quick query on this table, get some data and then play around with it. You can use Athena for that,
Okay.
right? Because it's once in a while, you're not constantly running the same query and costing money. You can do that. But then you can see here, you got SageMaker for ML. There's other use cases. So that serving layer basically says, here's a bunch of tools, right? Some ML tools, some analytics tools, some BI tools. We're offering it to you, the consumer. Go ahead, choose what you want, right? So you can think of that as kind of like your API. Does that make sense?
Yeah, that makes sense.
Cool. You had a question?
Yeah, I have a question around the data catalog registration part. So what I have seen usually is, aren't data catalogs supposed to sit on top of the consumption layers? Because that is where usually the users interact with the data. And then I see here right in the middle of all the action.
Yeah. So it's a good point. So data catalog is a big term, but in reality, it's actually multiple things. So I think what you're kind of describing is more like a business catalog, which is really there to serve the purpose of discoverability and understanding, right? How do I map a table in a schema to like a business entity, right? So if I have a table, is that a payment? Like what does that look like? How do I map it?
Like mapping the column to their business terms.
Exactly. This catalog here is a technical catalog. So this one says that most users probably won't go there, right? Because it defines the table name, the schemas, partition information, like technical bits, statistics. All those tools need that catalog to find the data, right? So if you run a query on Athena, you say select star from table payments. Where is table payments, right? What is the schema for table payments, right? So that engine needs that, right? So think of that catalog as a map, right? It's a low-level map that tells you what to do, right? Oh, where to go, where to find stuff. Where the business catalog is more of like Yelp on top of that map, right? Here's all the cool, interesting stuff. This is where you should look at, those kind of things. So that's why it's in the middle. In JPMC case, this actually is another layer. There's a business catalog on top of that.
Right.
And that's the one that has the business entities and things like that. And that's what that central catalog mesh was.
Makes sense now. Yeah. So this layer, so do companies usually build these in-house, these mappings, so there are specific tools for these? So
The business mapping?
Yeah.
Usually, so depends. Usually they build it in-house, they do it themselves because it's very specific to you. But there's also like taxonomies, right? So there's kind of pre-built models for like financial, healthcare, things like that. So you don't have to reinvent the wheel every time. But you start there and you always tweak it to your own.
thank you.
I think there's another question.
Yeah, I have one also about data catalog. So is this the kind of situation where there's centralized governance from the actual Google catalog lives there, and the producer has to overlay locate table there and then share the system back over the
That's the lake formation model.
most disgusting thing I've ever seen.
Yeah. So you jump to this. Yes. So okay. So this kind of talks exactly what you're saying. Looks like somebody has a question. So we'll get to that in a second. So you kind of have that left side and you have the right side, right? Those are the catalogs internally, the things that you want. And then the idea of lake formation is that if I want to share data from account A to account B, I have to create a share, right? A resource share. So inside of lake formation, it says lake formation account 1 wants to take a table and share with account 2. In this case, it shares it with the middle account, right? And that account reshares, right? So all those data sets register in the middle account, right? So all the tables get registered in the middle one, and then from there you share them out, right? And that's really, it's a little ugly, but it's because of the limitation of lake formation. So in lake formation, the resource manager that actually shares AWS resources, you cannot do transitive sharing, right? So you can't go 1, 2, 3. So you have to go, the middle one has to consume and then it shares out. So yes, you're right. It's a little bit ugly, but that's one of the approaches. And we'll talk about another approach in a minute. I saw a hand raised on the Zoom. I don't know if you guys are muted and can talk.
Yeah, I had a question here from New York. Can you guys hear us?
Yeah, we can hear you.
Okay, yeah. So the first question was, how do you promote reuse in this? Because let's say producer account 1 starts in January, and they're not at the point where like their infra is ready for producer account 2 to start using it. So they both are building the same thing, but from scratch at different paces.
Yeah, so that's a good question. So this really boils down to, so internally within your company, how do you build this out? So you don't actually build it out manually. So what JPMC build, they actually build they build a blueprint or a template, and the blueprint basically has all of these components, all these relationships, all these configurations kind of defined. So once you take the blueprint, you should be able to deploy it within one line of business, and then duplicate or kind of stamp that same blueprint in other places. And that's the benefit of having shared infrastructure and shared architecture, so you can actually create those blueprints.
But then it goes, so this is the confusing bit where like, then it goes back to the central platform team to have that blueprint ready, or like for them to create it. Because producer account 1, for example, is creating for them their own self and not thinking about everyone's use cases and so on.
Yeah.
So they're not going to
I
have
mean,
it generalized, etc.
Yeah, so in this particular case, the way this all started is like one line of business actually came up with this design and this architecture. They built the blueprint and then they shared it with the other lines of businesses. And those other lines of business kind of took the blueprint, maybe tweaked it a little bit, and then deployed it on their own. In a different environment, like if you're not JPMC, or maybe a smaller company, you may just have one, kind of one infrastructure where you're saying, these are the tools, this is the architecture that I want to use. No one team necessarily needs to manage it because you're using cloud services like S3 and Catalog. Like you don't need to manage those things. And then you come up and you say like, okay, the first team comes up, this is what they need. So they're going to launch this, the Glue service or, Redshift or whatever. And then another team will come up and they may launch something else, right? But the data is consistent. The way you store the data, the way you catalog the data is consistent. How you process it or what tool you use to process may be different, right? So you don't necessarily need to have a blueprint for all of it, right? You can either have a blueprint for everything, or you can say, I'm going to basically abstract away the common layers, like the storage, the metadata, the security layers. But then from a compute perspective, transformations, I don't care what you use. Use EMR, use Glue, use Databricks. It doesn't really matter sometimes. I don't know if I'm answering your question.
Yeah, no, that discussion was good. Thanks.
Okay, awesome. Any other questions? Need to move a little quicker. Okay, cool. So this is an example from Intuit. Again, very similar. If you kind of look at the reasons why they chose, to build a data mesh, is around treating data as a product, looking at data as code. That was important, right? How do we version? How do we track? How do we share? Responsibility and ownership was a big one. They're creating lots and lots of data sets, but nobody knew who owned what. And if there's a problem, who do you go to for help? That was a big one for them. So that's kind of I'd say those are the big reasons why they chose to go down the data mesh route. This is just an example of kind of how they broke it up. So if you look each of these smaller boxes, those are different microservices. They don't have necessarily lines of business, but it's a different microservices team. So you can see there's an identity service, there's a different things, a product entitlement service. So each of them is its own data domain within the data mesh concept. And then if you look, it's kind of hard to see the boxes, but the green ones are kind of data processing components, and the blue one are the data serving components, right? So each of these bubbles, each of these data domains have their own tooling for data processing, right? Some use Databricks, some use Glue and EMR, some use Spark and Kubernetes. They don't really care. right? They say like, here's some best practices. Here's what we recommend. If you choose to go use, I don't know, something else, not something standard, maybe we'll talk to you about it. But for the most part, you can do kind of whatever you want. And then the blue boxes are the different serving layers. Some of these services are saying, look, we're going to give you a table. We're going to put the table in a catalog, register it there, and the data in S3, that's how you get it. Others are saying, hey, we actually want to give you an API input, right? Because maybe your machine learning inference service wants to call an API. It's not able to read from S3. So we'll actually give you an API input. So they set up an API gateway and they offer that. But they offer that as a product, right? It's part of their service. They're responsible for it. If something doesn't work in that identity service, I know who to go talk to, right? If the data model changes, they don't just change it and break everything, right? They have to communicate that. There's a standard way to do that. So this is Zalando, large e-commerce out of Germany. They're kind of saying this is coming from the MLT side. We kind of have a lot of this data teams producing lots of data, very data-driven company. And then they have ML users, machine learning users, they have data users who are coming in and saying, we're maintaining this data for you. We're transforming it, we're cleaning it, we're enriching it. And then you got the business users on the right side saying, I want to make decisions. I want to build this model for recommendation. I want to change this model for personalization, right? So everybody kind of throws the problem over the wall and nobody solves it, right? And then keep kind of banging head, pointing fingers like we said in the beginning. So the way they kind of handled it, they sort of said, look, we got this bottleneck, one central data team. We're going to create this data infra as a platform, right? It's a common layer, common storage layer, common metadata layer, and then we'll give you some options for compute. They're a big Databricks shop, so they offer Databricks to their users for notebooks, for ML, and for engineering, data engineering. They offer, other options. They say, if you're a data team that's producing data, we're going to recommend that you publish the data over Kafka, right? So publish your data over Kafka. The data streams automatically into the data platform. We know how to handle it. It's standard, right? If you can't do it, okay, fine. There's other patterns. But for the most part, they kind of recommend, if you're going to bring data in, this is how you do it. Put it in S3 or put it in Kafka, right? And then they know how to handle it. And then on the bottom, it kind of talks about how they broke up that relationship and say, instead of having different teams doing whatever they want and trying to figure out how to talk to each other, they broke them up into individual data domains. And each data domain sort of says, this is my data, this is what it looks like, I'm going to publish it, and then everybody can consume it. So you have a bit more accountability. All right. So what can we learn from these case studies? The primary drivers in reality is autonomy, right? Each team has to be autonomous. They don't want to depend on one central team. Ownership is another big one. Finding data is great. Who owns it? How do I know it's good data? How do I know it's quality data? How do I trust that in 2 months from now, it's going to continue to be a good data? And I'm not building my service or my dashboards on top of something that's going to break and nobody's maintaining. And then data as a product. How do we think about data like we think about products? So we build reliability and quality and assurance into that data so we can continue to depend on it and not have to reinvent the wheel every time something breaks, right? Somebody goes on vacation for a week, you don't want the data to all of a sudden just go stale, right? It needs to be reliable because I'm depending on it. Sharing is another big one. The producer-consumer model, which we'll talk about in a minute, is a way of sharing, right? I'm a producer of data. I want to share with the consumer. How do I do that, right? And then building a common data infrastructure is another big one, right? You want to help reduce the cost overall. You want to standardize in a set of tools, makes it easier to choose. So not every time a team comes online, they say, wow, I look at AWS, 250 some services, lots and lots of vendors out there. How do I choose? Each one has to go test and validate. No, there's an infrastructure, a common infrastructure. We know how to secure it. We know how to scale it. We know how to use it. If you need help from me, I can help you. If I need help from you, you can help me, right? And then you can see some examples of what JPMC Zalando and Intuit did. And then that catalog, right? The data catalog at the end of the day really solves the problem of discovery and the problem of understanding. Right? Like I said before, there's kind of two components of it. I'll talk about that in a second as well. You'll see the breakdown. So with all this, I know there's a lot of stuff that I threw at you. If you have any questions, let me know. The next part, I want to kind of talk about, like, what do you need to consider when you're getting started? There's a lot of text here on the screen, but I think the 3 bullets are really about understanding what are the primary outcomes that you need to implement data mesh for. It's not outputs. It's not things I need to go do. Like, what do I actually want to get out of it, right? We talked about what the other cases, JPMC, Intuit, Zalando got out of it, right? Autonomy, ownership, data product. So you have that ownership and responsibility. If those are the things that's important to you, maybe it makes sense to go down the data mesh route. If you're saying, nah, I don't really care. I just want like a central catalog, and that's really all that I need. Or I need some access controls on my data. Data mesh is not for you. Don't go down that path. Don't bother, right? But if you're saying, hey, my central team is overwhelmed, I need to decouple. I need people to be independent. I need these teams to run on their own. Autonomy. Data mesh is a great way to approach that problem. The second one is data infrastructure. Do you build or do you buy? So that's a decision you need to make, right? Are you saying, hey, you know, Snowflake's great, solves my problem. I don't need a whole lot. I can just have one big Snowflake. Everybody can come in, publish data sets, just buy it, and that's it. That's all you need. That's great. But if you actually want autonomy and you want to separate, you want to control, and you want to offer data in a more reliable way, maybe that's not the right way to do it, right? So then you got to consider, do I want to build it all on my own like JPMC did? Do I want to build parts of it and offer, you know, buy parts of it like Intuit did, right? Or do I want to buy kind of majority of it like Zalando did, right? So it's your choice how you want to kind of stitch those things together, but it's something that you need to think about. And then the last one is kind of like, what are the most important outputs? Not outcomes, but outputs. Like, what are the things that you've got to go deliver in order to get the outcome that you want, right? So if the outcome you wanted is autonomy, what do you need to go do, right? You need to go talk to your company about what's the best way to build a process around different teams working autonomously. How do we talk to each other? How do we communicate changes to schemas, right? So there's things there that you got to figure out that are technical things that you got to go deliver in order to get the outcome of autonomy, right? Things to avoid or avoid early on, right? Don't try to solve loosely defined problems. I see this a lot when we talk to data mesh with customers. It's, hey, I want to build data mesh. What do you need it for? Everything data mesh wants, right? Like all these things. I need autonomy. I need this and this. Double click. There's nothing there. Like they've not think through what they really want to get out of it and how they want to approach it. So loosely defined problems will just get you spinning around in circles for a very long time, and you're not going to get anywhere. So when you hear people say, like, oh, I've tried data mesh for 2 years, I can't get it working, it doesn't work, it's nonsense, it's because they didn't define the problems, right? They don't know what they're building it for. They just know they're building it because somebody says go build it, right? Or they saw it online and they said, wow, it's a cool idea, let's go do that, right? Define the problem. Don't expand your scope, reduce it. I see this so often where you kind of go down a path and you're starting to do stuff, and then somebody says, let's add security, let's add governance. What is governance, right? Governance is a lot of things. So again, we're back to the loosely defined problem. So now we keep expanding the scope and it becomes harder and harder. Stay focused, stay nimble, you'll be able to deliver value faster. And then don't overcomplicate your architecture. I see oftentimes people say like, oh, but DBT is cool, and Snowflake is cool, and Spark's cool, and Flint's cool. I'm just gonna throw them all in, right? I wanna use it, I wanna use this cool, and this company, this cool startup that does data cataloging just came out with this AI thing that finds data sets for me automatically, classifies them. I want to bring them in. I want to do this. Now you end up with all these bolt-ons and they don't really talk to each other. They have different maturity levels, different security capabilities, different scalability and cost. And then you just kind of like completely wasted all your time. And you're never going to deliver on that one outcome that you really want to deliver on. All right. I'm going to kind of go through this and then Jason's going to go into a demo. So getting started with organizational autonomy. I simply want to get separation between my teams. Actually, I see a hand. Do we want to jump in and ask questions or we want to wait?
You can take a question. It's from New York City.
Okay, go ahead and ask.
Hey, hi. The question was on 2 slides back when you were talking about data as code. And the question is, how do you actually enforce data contracts? Because these are between internal teams, and on like a tactical level, people really care about revenue and things that are external. And that's where SLAs kind of get enforced properly. But internally, it's very hard to come up with a good system of, okay, we align on the SLAs, everyone aligns on the SLIs, and then the contract is like actually taken care of. What are some ideas on how to implement this now?
Yeah, so I talk a little bit about it towards the end. I think the idea of data contracts is a little bit broader. There's different kind of components to it, right? There's sort of the data contract itself, which is how do we agree on the data model, like what the column names, column types, those things. There's another component to it with regards to data quality. How do we ensure that when I deliver you that data, I'm meeting the quality contract, right? And then you have the SLA component. If I'm saying that data is going to be available and refreshed once an hour, you got to make sure that it's done, right? And I need to be able to communicate to you when these things are happening. So if I'm missing my SLA, how do I communicate that to you? So in essence, this is more of like a conversation between the data producer and the data consumer to say, how do we align our expectations? What I've seen is that more of these data product managers are kind of coming into that conversation to be that gap, the bridge between those two teams, right? How you encode that information, how do you then enforce it? It's more of a technical conversation. But for the most part, you have sort of like a coming together to say, I'm a data producer, this is what I can offer you. And then you, Mr. Consumer, you may do different things with it, right? Maybe you consuming the data, I'm going to apply a different business model to it than me, right? So we don't want to necessarily force a contract that is too specific or too generic either. So it's more of a conversation of how do we structure it in a way that serves, you know, the broader need of users. Does that help at all?
Yeah. Thanks.
Okay. Yep. All right. So, you know, if I'm getting started today, right, and I want to say, hey, you know, data engineering team is a bottleneck. I can't wait for them. I can't depend on them. I want to be more autonomous. This is a simple way to get started, right? And all it means is that I'm going to start with a data lake. Data is always in S3. My data is cataloged in the catalog, right? The technical catalogs. And then I have a producer and I have a consumer, right? So one particular team says, I'm producing data sets. You can then say, take those data sets, produce them. I want to store them in my data lake, right? So they write the metadata to the catalog, data in S3. You're pretty much done. Now you have a data set, right? Now consumers can come in and say, okay, we have a number of tools that we can consume that data. This is typically for analytics, typically for BI use cases, any kind of use case that you can query the data, but it gives you that separation. You can go into data contracts where you define what the schema looks like and things like that, but you don't even need to go that far, right? The table definition in the catalog, that is kind of your baseline contract, right? If that thing changes, somebody needs to be notified, right? And that's more of like a business process to say, how do I notify if I want to change my schema? But at a minimum, that gets you started very quickly to say, payment team, you know, whenever you produce your data, I want it in this location. And when you define your schema, I'm going to sit in the catalog, right? And don't change it. If you're going to change it, we need to have a conversation on that, right? And that's basically a very simple way to get started. And this is something that I've seen lots and lots and lots of companies get started with this idea. And you can call this a data mesh, right? This is the autonomy, this is the separation. You may have multiple producers, maybe one consumer, maybe it's really like your sales marketing teams consuming the data, but the producers are your payment team, your backend team, your recommendation team, they're all producing data sets in a more consistent way. Extending that a little bit, you know if it's a different question or the same hand raise?
It's the same.
It's the same one, all right. I don't know if it went away or not. So extending this a little bit, right? Now we want to say, okay, we have some autonomy, we have some separation, we're getting bigger, we have a lot more data sets. We want to make discovery actually better, right? So this goes back to the catalog, right? Now I have the technical catalog that's storing my metadata, right? My location of my data and what structure it's in. But I'm going to layer a business catalog on top of that, right? So companies like Atlan, lots of others that can sit on top that extract the metadata from the data catalog, collect other information, put some business processes around it, some more modeling, entity modeling on top of that. And now you have a place to go search. You have a place to collaborate. You have a place to rate and star and play around with the data and tag it and do those kind of things. And that really introduces that central discovery aspect across your organization. But the access to the data still comes to the consumer. The consumer goes to the catalog and says, I want these data sets. Cool, where do I find them? Cool, they're over here. I'm going to go back into my query engine and I'm going to query them, right? And then if you want to add some observability on top of that, so how do I know if a data set is good? When was it last updated? Where, what's the quality metrics on that one? Observability tool is something that will go around and pull all that information and then enrich the catalog information with that data, right? So now you can look at the data set and say it was last updated an hour ago, right? The data quality validation passed, or this particular one failed, right? You get lineage information. So now you get more enrichment of the data. So when you actually look at it, it's not just discovery, it's discovery plus understanding, right? And you know who the owner is if you need to go fix it. And then access is the same as the previous example. So this last one is if you want to say, cool, autonomy is great, discovery is great, but really important to me is I want to start operating as a product. I want to build data as a product. And this is to the question, I believe from New York earlier, how do I do that? The easier way, or I don't know the easier way, but like the simpler way to get started is by taking the idea of GitOps, right? Everything through version control, right? So again, we're treating a data contract as code that basically says what my schema looks like, column names, column types, data quality expectations, my SLAs, some other comments or other information in there. That's all checked into version control, right? So the producer comes in and say, this is the contract. Now a consumer may come back and say, like, look, I'm not okay with that. Or, hey, I need better explanation for this. So this SLA isn't good enough. If I'm going to consume that data, a 5-hour SLA is not good. I need it to be an hour, right? That then become a conversation where we're kind of using code patterns to say, do a pull request to the contract, change something about it, enhance it, whatever, and then the producer kind of approve or disapprove, and we can have that conversation. Just like we do code reviews, right? The contract shouldn't be any different. The same thing for the code, right? If my team is then saying, okay, I need to take that data, I need to transform it, that code now is checked into version control, right? So everything is in code, maybe less that drag, drop, click, ETL tools that are not easy to version, not easy to reproduce and test, everything through code, right? So you'll see later in Upsolver, we do everything through SQL. So all your transformations, all the connections that you create, everything is in SQL. So I can take that SQL code, check it into GitHub, have Jason review my code, make sure I didn't screw anything up. And then if he's happy, he pushes it to production. Then I want to change my job. I submit a pull request to that job. Jason again approves it. And if it's good, he publishes it to production, right? And that's how we have data as code, and we're making sure that everything is consistent. If later somebody wants to come in and understand the contract, they can go to GitHub, they can see it. They can see all the revisions. They want to know, what did Roy did? Like, how is that table calculated? They can go to GitHub, they can see exactly the code, they can see exactly how I did it. If they think it's wrong, they can submit a pull request to it, and then we can change it, right? So we bring that in, we define the contract to it, we then define the transformations, we execute the transformation, and then we serve the data. How do we want to serve it? Oftentimes for analytics, just put it into my Snowflake, right? Take that data set, write it into a table in Snowflake, I'm going to query it in Snowflake. Okay, awesome. Maybe I want to write into the data lake. Then I can use a tool like Amazon Athena or Starburst, Presto, Trino, whatever tool you want to query data in the data lake, you can then consume it from there, right? But that's an option. If you're a producer, I may say, you know what? I'm only going to produce data to Snowflake. That's the only way I do it. It's the only way I support it. Okay, that's your choice. If your users come back and say, no, we want more options, then it's up to you as a data producer to add them or not, right? But you're in control. Or you can go a step further and say in a multi-tenanted environment, I want to take my data and I want to actually publish it to the other account, right? This way that account is not coming to me to create the data. I'm giving the data to them, right? Now they get the best performance because they're not coming to me. Yes, there's some data duplication, but they're in control of the data. They get better performance. They can run their own tooling around it. You're not paying for the compute bill. They're paying for their own compute bill. So there's benefits. There's of course pros and cons, but that's kind of the idea. And then you lay the business catalog on top of that, right? The catalog on top of that can catalog stuff in Snowflake, in Redshift, in the data lake. Then you have a single view of everything. So this is kind of the idea, general idea of what data as a product and data as code looks like. And of course, this can be expanded in many, many ways. But if you start simple, I would say GitOps, right? Put your code and your contracts in GitHub, or GitLab, whatever you choose. So you can actually collaborate with your team on this and make sure there's version controls and audit trail. And then kind of say, this is how I'm going to process, and then what are your options to serve that data? So that's, I believe that's my last slide. Any questions on this one? Oh, just a summary slide. So, okay, just a quick summary, and I'm going to hand over to Jason. I think I went way above. So data mesh, it's really an organizational pattern. Don't think about it as a technology. It's not an architecture. It's not a solution. It's an organizational pattern, design pattern. You don't have to take all of it. You can take pieces of it. Take what makes sense to you. But remember, you need to get your organization on board. Right? You don't just come in one day and say, oh, it's Snowflake now, everybody's happy. That's not data mesh, right? You've got to get people on board, change the way they're thinking, get them to start thinking data as a product. Focus on what you need to build now, right? Now that you understand what problem you want to solve within data mesh, focus on what you need to deliver. I see way too many people just kind of jumping around and adding stuff and want to do more and more and more and more, but that just kind of gets you off track and you'll never deliver anything. And then last one, treat data as product, right? Think about it as a product, treat it that way, have owners, have reliability, have good consistency with the data, then you're going to get better results. Jason?
Yeah.
Cool.
Switch.
We'll leave these QR codes up after I finish.
No. Okay, thank you.
So I'll give you the Cliff Notes version of a demo here. I'm sorry, I forgot to get Zoom out of the way. There it is. All right, so I'll start this by saying and kind of echoing Roy's comment around, data mesh isn't a product that you can just buy, right? You can't just buy a product and say, oh, boom, we're data mesh. Right, data mesh is more of a philosophy and organizational structure that supports a lot of the concepts that Roy discussed. And so in the same vein, Upsolver is not a product that inherently gives you data mesh, right? Upsolver is a streaming ETL platform that leverages data lakes to help customers embrace and adopt data mesh practices. So architecturally, Upsolver is a streaming ETL platform that uses a data lake to process data. Right. So if you think of an architecture, you've got your sources of data over on the left. It's kind of a simplified version of some of the eye charts that Roy showed. Over on the left, you've got your sources of data, and these could be streaming inputs like Kafka, Topics, Kinesis streams. These could be S3 buckets that you store raw data in, JSON, Parquet, or Protobuf, CSV, TSV, any type of raw file format that you might be storing in S3. Or these could be your traditional database sources, right? Postgres, MySQL, any sort of relational database target that you might want to bring data into your infrastructure with. Upsolver is going to read that data into your data lake, and we do so as a stream, right? So everything that you do in Upsolver is done as a stream. We process batch data row by row. We process streaming data event by event, and we can do so in near real time. We're going to build out a data lake, a managed data lake on that data that we're reading in. Right, so when Roy talked about cataloging, S3 buckets, data lake tables, all of that happens inside of effectively Upsolver, right? This is what we are, right? What you see inside of this dotted box. So there's a lot of subcomponents of that stateful streaming engine, but just think of this, we can read data, we can process it, we can stage it, and then we can transform it all within kind of the Upsolver ecosystem. right? And then finally, we can write data out to the targets that you want to write out to. Think about the data consumer model as Roy talked about, or the consumption layer. These could be data warehouses like Snowflake or Redshift, or you could attach query engines to the Upsolver data lake and query raw data in its lake-based form, right? So you could use Athena for that, Presto, Trino, Starburst, Dremio, anything that can read from an AWS Glue data catalog managed table can read data that's been transformed by Upsolver. So I know this is tough to read through the flashes, but this is gonna be really interesting to show you a demo through a screen that's only half working, especially one that's very code-based. So Roy had mentioned that the interface into Upsolver, we've got this graphical interface delivered through the browser, but the interface is SQL, right? So it's the most common language that most data professionals are most comfortable in, right? So all of your pipeline management, all of your building, all of your management, all of your data pipeline processing is done through SQL. This is the UI on the left-hand side of the screen. You'll see the components that make up your pipelines. Worksheets, this is your IDE effectively that you build your pipelines in. Let me figure out a way to zoom in if I can get the, there we go. Zoom in, perfect. All right, so we've got your worksheets, it's just IDE, basically a text editor that you can build SQL commands in. You've got jobs. Jobs in Upsolver are what processes data and moves it from stage to stage. And you've got clusters. These are the managed components that do the work required to process data. Right? If we open up a worksheet here, and I'll fit this into the sort of data mesh concept that Roy talked about in terms of data producer, data consumer. Right? A data producer's job is to get data and then present it in a way to the business that they can start to do their thing on with it, right? So if I'm a data producer or data engineer, however you might fit into the world, this is a worksheet with some SQL statements that allows you to do exactly that. You've got your catalog over here on the left. These are the connections to your source data that you might be reading off of. Connections are created using simple SQL commands. So create connection to Kinesis with this username and password. Effectively, that's it. We then build tables in Upsolver that are defined using a pretty simple SQL syntax. So create table, that's pretty self-explanatory. You'll notice empty parentheses after the table name there. And so that just means, or that reflects the fact that Upsolver is going to automatically define and infer the schema based on the source data that we read in. And will automatically manage the Glue data catalog as we read that data. So if you tell us to read from a Kinesis stream that's got JSON events loaded onto it, we infer and automatically create the schema of that table as data is read in, right? That allows us to really effectively handle schema evolution, right? Where you've got events showing up on your stream. Starting 6 months ago, we had these fields and these columns and this data type, and then over time that changes, right? We automatically update and modify that data catalog as we read new data into these tables. The only thing we're really defining there is a partition column. That $sign there, that indicates the system column. The date that we read the event in, that allows us to partition your data lake table so that it can be efficiently queried, in this case, by date. Right? The second command here, this is a SQL statement that starts reading data from some source connection and loading it into that data lake table. So pretty simple syntax, create a job, start from the beginning of time or the beginning of when data was loaded into the source. We're looking for JSON. This is an S3 source. So we've got a system that's loading JSON files into an S3 bucket partitioned by date. So we're defining a date pattern, and then we're loading that data into that table that I just created. Right, so pretty simple syntax, just create a job, read from S3, look for JSON files, and load it into that table. Right? Now, that table, once you create a job in Upsolver, this is an important distinction. Jobs are not things that you like schedule to run at a frequency, right? A job is always running, right? You create the job, it runs 24/7. It's constantly looking in that S3 bucket for data. Once it finds it, it pulls it in, ingests it, infers the schema, updates the catalog, and then stages it in the table so that it can be effectively used. All right, so if I look over here in my table, I've got my raw data table that is over here in my producer catalog. And we've been loading data in, we've been calculating statistics on this table, we've been inferring data types, we know how many distinct values, basically know all of the statistics and metadata about the data that we're reading in, and we constantly update that catalog as we find new data to ingest and analyze. Right? Now, this is so far what we've done, we've created a connection, we created a table, and we created a job that runs 24/7 loading data from that source. Now, from here, we may now want to produce refined data sets, right? We've got this raw data. Raw data is inherently nasty, right? It's got fields that aren't right. It's got data that we need to scrub because it's got PII in it. We've got maybe nested JSON that we want to extract into separate columns. We've got arrays that we need to figure out how to deal with, right? What if we want to aggregate on an element that's in an array? How do we do that row by row? So as a data producer, I can now create different transformations on that data so that I can present it to my consumers in the way that they need it. Right? Where I talked about contracts as one element of that. My consumers are expecting data in a clean, filtered, redacted, and maybe flattened form so that they can start to do meaningful things with it. So here's an example of a job. The run interval there, that's your freshness of this data. All right, we can go as low as 1 minute. So this job's going to run. It's going to run constantly, 24/7. It's going to write to an output table once per minute. This SQL that you see here is what transforms the data, right? So pretty simple syntax. It's nothing really that revolutionary about the syntax itself. We're applying a hashing algorithm here to an email address to make sure that we're protecting our PII. We are using a string function here so that we can normalize all of the order types so that upper and lower cases are all the same thing. We are calculating a field here. I've seen this in a lot of data sets where companies or developers can't figure out a consistent way to name countries. We've got USA, we've got US, we've got United States, we've got, so we can kind of normalize some data and then we can write that cleansed data set out to our consumers, right? So I'll show you what this looks like here in a second, but this job's now going to run 24/7 in near real time, cleaning our source data and writing a refined data set out to our consumers. Here's an example of a data redaction, right? We've got this massive volume of source data, hundreds of columns, billions of rows. Our consumer doesn't need all that, right? We could put a simple where clause on the data to filter out events that you don't need. We could put column filters on. Instead of select star, let's select the columns that our consumers need to provide their analysis. So that's a simple redaction use case. And here's a flattening use case. Again, you've got nested fields, you've got arrays. To flatten data in Upsolver, you just take a select statement, wrap it in this unnest command, and now your data is flattened, right? Instead of one row with an array of lots of entities in the array, you've got one row per entity in the array, right? Just a simple flattening exercise that then allows you to do more interesting things when it comes to aggregation, right? So if I put my kind of data mesh, data producer hat on, I'm now producing data sets for the consumers that are clean, redacted, and transformed in a way that they need it to provide their analysis. If I now put my consumer hat on, I can use the same solution, right? So again, this is not a product that is data mesh, but it can help customers take advantage of data mesh concepts. I can now start to query these data sets as data lake tables, right? So here, for example, is my corrected data set that has the customer email address hashed. It's standardized on my order type so that everything's lowercase. If I scrolled over, I'd see the rest of the columns that I fixed. But now this data set is updated in near real time, streaming event by event or row by row as data comes into my system, and it's in the way that I need it. If I want to look at my flattened data, I'm not going to show you the source because of the time reasons, but again, this data set had array elements in it. We had for every order, we had an array of items, and each item had associated fields. Now we've got for each order and for each item, we flattened that array into separate rows. And again, this is kept up to date in near real time as data is processed through the system. Yeah.
5 minutes left.
Yeah, we're good.
There's a question if you want to take it now or later.
I probably only have like 40 seconds left of my demo, so I'll do that and we'll take any questions that might have. Right. And then finally, so we've got our kind of cleansed, refined, redacted, transformed, flattened data sets that were created by our data engineers or data producers. Now I need to then create these data products, data apps, refined data sets that are analytics ready, right? And this could be pushed out to our data warehouse. This could be left in the data lake and attach a query engine to it. But now I can simply create jobs that build on top of these data sets and kind of create data in a way that it needs to be consumed by our business users. Here's an example. So again, remember this is a raw data set. We had an order, we had an items array inside of that order. I needed to flatten it so that I could aggregate by some element of the array, right? So we first flattened it. Now we aggregate it, right? And so here's an example. Aggregation by SQL is pretty simple. Right? Group by what you want to aggregate by, and then apply some function to a column to aggregate. So that's what you do in Upsolver, right? Here's the select. So you're selecting some fields, you're grouping by the item ID and the order that the hour was placed. We're calculating revenue, and then we're summing the revenue, right? So an item in the array, truncate the order date by hour, summing up revenue, and then writing that out to a target for analysis. In this case, we're writing out to Snowflake. So you can see the syntax here. It's creating a job, read from the beginning, update it every hour because we're really careful about Snowflake costs. We don't want to write too frequently and get some sticker shock on the bill. But once per hour, we're now going to update our Snowflake table with our hourly aggregate of an item that was nested inside of an array in our source JSON data that came out of S3. Right? And that entire pipeline is now managed by Upsolver. If you don't want to write to Snowflake, you want to leave data in the lake. There's some advantages to that, one of which is we don't have to be as careful about cost because lakes are inherently less expensive. So we can write to a data lake table. I probably should have said 1 minute there as my run interval so I get more frequent updates. But here's the same transformation writing into the data lake where Athena or Starburst or Dremio or Trino or Presto or any of those lake-based query engines can now access our managed data lake tables. So that's kind of where Upsolver fits into this. I guess I'll show you the end result. I shouldn't do a demo and not at least show you what the results look like. Here's my data lake output. Again, I've taken my raw data from S3 with nested JSON and array elements. I've flattened them. I've extracted an item ID out of the array. I've truncated a timestamp to the hour. And then if I scroll to the right, I will see the aggregate values that I can now feed into my analytics engine to create dashboards or reports or whatever the business might need. If I'm doing the same thing, I thought I had my laptop. On my laptop, I have a Snowflake worksheet open. I can show you the same query in Snowflake, but honestly, it's not that interesting. It just happens to be a Snowflake interface. But so that's Upsolver. Again, we are not data mesh, but we are certainly a streaming ETL platform that can manage a data lake for you and help your company kind of produce or implement data mesh concepts inside of your data practice.
Okay, if you were to kind of map it to some of the pictures that we had, I think it's the kind of like basically Upsolver. You can think of it as that infrastructure as a platform, platform as infrastructure, whatever you want to call it, right? That's a little layer that cuts across the organization. Producers can use it, like Jason showed you, produce the data, transform the data, then they can publish it to other consumers. Consumers can still use the same exact platform if they want to take that raw data and do something additional with it, like, model it for their own use or whatever. Then they can then produce it to other people. So consumers can be producers, producers can be consumers. They're using the same platform, consistent experience. And like you saw there, I can always go back and see Jason's job that he created, and I can double check what he did. I can look at the table metrics. I can see, was schema changed recently? The data quality change? I can look at those statistics directly in the platform. So, granted, it's not a data mesh solution, but it is a platform that allows you to actually get started with the data mesh quickly.
Yeah.
You want to take the questions as well?
Kind of a cool use case where somebody who's consuming data wants to see like the lineage of how data got to where I started picking it up, right? So it's one of the nice things about just our transparency. And here's my raw data table. Here's the schema of that table. Here are the fields that I'm seeing, so I can kind of inspect the quality and distribution of data. If I scroll down, I can see the job definition of how we're inspecting data. So think of this as like, I'm a data consumer, but I need to know how this table, this theoretical landing zone of data was built, so I could see where the bucket was, what the file format was, what the data was inside of that bucket. It's a really nice way for kind of teams to collaborate with full transparency into each stage of the process. process.
There's a question online if you wanna.
Yeah, let's go to Poonam in Chicago. She has a question. Go ahead.
I think the question was, how does it differ from KSQL and Kafka Connect?
Yeah, so the question was about like how we differ from KSQL or Kafka Connect. So Kafka is one component of data that we can read. So there's a I guess a broad difference between Upsolver and Kafka in that Kafka is effectively a streaming platform that can store and process events. Upsolver can read those events and then transform them by, we could do independent, read from Kafka, transform, and then write somewhere, but we can also like join a Kafka topic with some batch data that you have in S3. Or we can take a Kafka topic, join it with Postgres data, join that with reference data, and then push that to Snowflake. So the simple answer to that question is that we're bigger than just Kafka and we're more heterogeneous than Kafka. But that's probably the
Yeah,
simple
I would add that Kafka Connect is basically like a connector framework that reads from places and puts stuff on Kafka. KSQL DB is, think of it as like a SQL layer on top of K streams and K tables, which are just components inside of Kafka of handling data. It sort of feels similar from a streaming job perspective, right? But it doesn't have a lot of the things that Upsolver does, like data quality, some of the observability things, integration with data lakes and catalogs. Like from KSQL, if you want to write into Snowflake, you got to go back into the Kafka Connect ecosystem, right? Writing to a data lake is not as easy, right? You still have to manage the KSQL DB clusters that then connect to the Kafka clusters, that then connect to the Kafka Connect clusters, right? There's a lot of components there that you're still managing, where Upsolver is a fully managed platform. So
that's a fair thing to mention. Like I showed you kind of the interface to Upsolver, but honestly, where most of the, not to be corny, but where the magic is in all the infrastructure that we automatically orchestrate behind the scenes to make this all happen, right? How we scale up and down resources, how we handle delays in data, how we handle fixing problems, how we, so all of that infrastructure behind the scenes that runs in AWS. So you literally, I mean, we use this marketing tagline, right? You write like 4 lines of SQL and we infer and orchestrate an entire end-to-end pipeline, brings data from the source, writes it out to the target. We handle all the dependencies.
there was another question, I didn't quite read the whole thing. Did somebody want to ask that question about like aggregation, I think? I can pull it up.
Okay.
Was it in a chat? Oh, here we go. Oh, could you please tell us how stateful aggregation works in the case of late arriving data in enormous?
Do you want to take it, or do you want to?
How much time do we have?
Can you do it in 2 minutes?
So that's a great question, and it's honestly one of the main reasons customers come to us. So there's a couple points to that. So first of all, as we read data in from a stream, we can kind of manage our own state store on top of that streaming data. So we kind of call our key value store a materialized view. It looks and functions and feels much like views that you might create on databases, right? So you write a SQL, you get a materialized view that has key columns and has values associated with those key columns. And we handle the creation and automatic updating of that state store as data is read in from the source. Right, so as we read it in, we update the aggregations, we update our materialized view, and then you can use that materialized view as your state store to join other data into it to build out your transformation logic. So we don't use like a RocksDB or some external key value store on top of the stream. We effectively read data from the stream and become your state store.
Can you show a materialized view?
Yeah, I can show you the syntax. It's honestly no. Maybe this is a good thing. It's pretty boring because it's just a select statement. Let me show you. I'm sorry, where's the search bar? There it is. So the syntax, so this is an example where let's assume I'm reading data off of Kafka, and I now want to create a state store, key value store based on that Kafka stream. We've already shown you how you can read data from a source, load it into a staging table. in SQL Lake, and then you build a materialized view on it. And it's basically key columns and then aggregate values. And then if you scroll down here, this is our transformation that basically joins some data set with the materialized view, and then creates a transformation that joins whatever the data is into that view structure.
Yeah, and I think just to kind of add to that, right? Like one of the differences is that our state store is actually two pieces. The first part is a cache that's compressed in memory. So each of the nodes in the cluster has that state information that when you build a materialized view, we can constantly look back and aggregate or join or handle the late arriving data. And then all of that state get continuously serialized down to S3. So unlike Spark and Flink or even Kafka, they store all of the state in RocksDB, which is maintained on the hard drive. So if you're doing a lot of shuffle, like data moving between nodes, you eat up a lot of your hard drive space. And on top of that, if you're doing state, like large state windows, like hours of state, you end up running out of memory, both memory and hard drive space. We actually put it all in S3, right? Additionally, in Spark and Flink, if a node goes down, you actually lost all that state. You lost the state, you have the state that's maintaining other nodes, but the one node lost that state. So you're gonna have to reshuffle and regenerate that state, where in Upsolver, it's all in S3. So if a node goes down or you need to spin up more nodes, we can very, very quickly hydrate those nodes with the state from S3. So that actually allows us to scale up and down and recover from failures much faster for stateful transformation on streaming data than Spark or Flink does.
There's another question too about how like maintaining sync and what happens, or maintaining state and what happens with late arriving events. You may have noticed that sync keyword up in there in the syntax. So everything that you load into Upsolver has a time value associated with it. The time that the data showed up on the Kafka topic, the time that the file showed up in S3, the time that the event was ingested from PostgreSQL. So this sync concept here makes sure that as you build that transformations, all of those steps are synchronized by time.
Right.
To ensure that you're not joining current data with data that was showed up a few hours ago, but was late and we just got a hold of it, right? And you get these inconsistent transformations because the streams are out of sync. So when you build transformations in Upsolver, it's just a sync keyword, but that basically tells the platform to make sure that all the data sources are synchronized as data moves through the stream. You don't have to do sync. If you don't care about that, you could leave that off. But sync is kind of a best practice just to ensure, especially when you're joining data and want to make sure you've got consistent states of data as data moves through the pipeline. We just kind of handle that through that keyword.
So I think we need to wrap up.
Yeah, we need to wrap up. I think there was one more quick question that we got from Zoom from Candy, which was about vendor lock-in. And can you avoid that? Is it easy to shift from one big data vendor to another?
And I'll say yes. Obviously, with I know that I'm here speaking as a vendor, but one of the nice things about Upsolver is that all of our file management is all open file formats. So we started on S3. Typically, most of our data is in Parquet. So we can help customers kind of avoid that. That's one of the challenges. If you just load everything ELT into Snowflake, now your data's in Snowflake, good luck getting it out. We kind of, all of our data is maintained in S3. It's your S3 too. It's not our S3, it's your S3. So if you want to kick us to the curb, you stop using us. You've got your S3 buckets with all the Parquet files that we've managed stored inside. So we are a vendor, obviously, but we use open file formats, really open specifications in terms of how we manage it.
Yeah, open file Parquet, but on S3. As a person who works with Google Cloud Platform.
Not yet. So we don't have any native integration into GCP. Roy can speak to roadmap on where that might fit, but right now our system runs in AWS, so it's S3 storage.
What is any plans timeline for
To read from GCP or to run on GCP?
To start first to read from GCP and then to write from GCP?
BigQuery, GCS, which
to read from GCS and to write to GCS or BigQuery, yeah.
Yeah, so we support GCS today to be able to read and write from GCS. I think we also have, we have the support. It's not in the current in the product in GA, so something that we do.
Better.
Yeah, and then BigQuery, we can easily support that as well. So if it's an interesting use case for you, love to connect and
Okay.
Yeah, we have, one of our customers is they're running in AWS, but they're actually, this is a security use case. They're reading security logs, technically VPC flow logs, Azure NSG logs, OCIs, Oracle Cloud logs. So they're reading from those cloud storage services, but they're bringing all that data into S3, transforming it, and then building effectively a data lake on files that come from all major cloud vendors. So we don't run on GCP, but we can read from GCP, and then we have options.
Awesome. Well, that's about all we have time for. So thanks so much, Jason, Upsolver. Thank you, Roy.
And Roy, so you obviously heard a lot from Roy. I'm a systems architect, Dave is the account executive that handles this area. We'll stay as long until Chris kicks us out. So if anybody has any further questions.
So 10 more minutes, and Chris kicks us up.
Yeah.
So yeah, if we could stay for a few more minutes. But again, thanks everyone for coming. Please do keep an eye out on your emails for updates on upcoming meetups. We do have our next meetup scheduled here in Boston, which will focus on Trino, and that'll be March 8th. So we hope you all can join. And we hope to see you all again soon. Thanks again.
Yeah, thank you so much. Yes, thank you so much.
Yeah, you got it.
This was awesome.
Yeah.
Appreciate it.
Oh, you're welcome. I'm presenting through a camera that's on your.
I know.